So this is Algebra 2 with trig. Working on Unit 1C.2b. We're going to solve quadratics by finding and using square roots. So as we look here, we have 5x squared. And that's going to equal a number of 80. So what we're going to do is isolate our x squared. So we're going to divide by 5. X squared equals 16. 5 goes into 80 16 times. So now we want to get rid of that square. X times x is x squared. So a number times itself is going to make 16. Most people consider 4 times 4 to be the obvious answer. But when you take the square root of both sides of an equal sign, you've got to be sure to incorporate the plus or minus. You must have the plus or minus, because your answer up here, you could plug in -4. Square -4 to get positive 16 times 5 is 80. On letter B, the first thing that we need to do is start to isolate the term that has the x squared. So we need to move the 16 over first. So because we're going on the opposite side of the equal sign, we are going to add 16 to that. That gives us 2x squared equals 50. Now we want to isolate our x squared, so we are going to divide both sides by 2. And we can take the square root of both sides. I'm rewriting it to take the square root around it because I want you to be sure you see the different steps. But I would expect you to put square root symbols right over your x squared and 25 on the first row, but your choice, how you would like to do that. And when you take the square root of both sides, you're going to get plus or minus, and the square root of 25 is 5. So think about it when you plug in your values to the original problem. When you plug in a -5, you would square that to get a positive 25 times 2 would be 50. 50 take away 16, that's where we come up with 34. You can check your work so you know if all these answers are correct. This one's a little bit different. Notice that it has parentheses. The common mistake is to add 6 to the other side, but you can't get it out of the parentheses like that. The only thing we can start to do is to work our way towards that center, towards the parentheses. So we're going to multiply by the denominator, and multiply by the denominator to both sides of the equal sign. That gives us -6, or x minus 6 squared, and 32. So because we have a term that's being squared, this is where we go about and use our square root. We're going to take the square root of the left side. We're going to take the square root of the right side. That theoretically will be plus or minus now. When you take the square root of both sides, you get plus or minus. When you square root something that is squared, you get the number that's inside. So we get the x minus 6. And this is going to be plus or minus the square root of 32. So this is how we're going to come up with 2 different answers. So we're going to add our 6 to the other side, because we're trying to isolate that variable. Notice where we put the 6. We put the 6 before the plus or minus. A common mistake is to put it before the radical, so it's plus or minus 6 root 32. But you need to have the 6 before the plus or minus. The plus or minus is affecting the radical. It's not affecting the 6. Now 32 can be broken down. 16 times 2 makes 32. So that gives us 4 root 2. So 6 plus or minus 4 root 2. That is not 10 root 2. That definitely isn't 2 root 2. You cannot do 6 plus 4. You got to keep them separate. So that's our two answers. 6 plus the square root of 6 plus 4 root 2 and 6 minus 4 root 2. So here you've got to make a decision on what you do first. So try to make your decision now. What does it look like you're going to do first? How are you going to get to your x squared eventually all by itself? The logical step is to add the 6 to the other side. Now we have the x squared divided by 25. So we're going to multiply by the denominator to get that by itself. And this is x squared equals 100. Then you're ready to take the square root of both sides. And x equals plus or minus 10. All right, our next set of questions that we're going to talk about is dropping an object. A lot of people look at this example and they think that when you drop an object, this is the path of the object. That's not quite clear. That's not quite true. The object would come straight down, right? If you reach outside the window and you drop an item, the item drops straight down, not necessarily at a distance away. That would be throwing an object. But the way this graph is made is you look at your x values, and that's time. In terms of time, your graph is made differently than the actual path of the object. At 1 second, you're at a height. At 2 seconds, you're dropping even further down, and then eventually you hit the ground. So mathematically, you can plot your graph, and that is different than the path that the object is falling. So when you drop an object, we're not tossing it, we're not hitting it, we're not kicking it. We're dropping an object from a certain height. That is going to be h of t. That's the height in terms of time. It's going to be negative 16 t squared. And we're translated up the height of your original amount. The original height, h of o. The negative 16 is the gravity aspect of what's going on. That won't change. That's part of the formula. The part that's going to change is your h of o, the original height that you're dropping the object from. So when we flip to the other side and look at a story problem that deals with this, we're dropping an object off of 240 feet. So this is 240 feet. You're standing up there at the very top. You're holding your item. You're going to drop it straight down. So we're working with h of t equals negative 16 t squared plus h of o. That's the formula that we're using. That's the formula for dropping an object straight down. We have negative 16 t squared plus 240 because 240 is the original height, is h of o. Now the question, it isn't when is the object 10 feet from the ground? When is the object 2 feet from the ground? It is when does it touch the ground? What is the height? The height is 0. We are looking for where this is 0 in this question because they want to know when does it hit the ground? How long does it take to hit the ground? So we're going to minus 240. That gives us negative 240 equals negative 16t squared. We're going to divide by 16, actually at negative 16, and we're going to find that t squared, when you divide 240 by 16, we get exactly 15. So the time squared is going to equal 15. So we're going to take the square root of both sides, square root of the left side, square root of the right side, and that gives us time is going to be exactly the square root of 15. Now we're not going to consider plus or minus in this situation because we don't want a negative time. We only want positive time. On a graph, it's going to exist at negative square root of 15 also. But in reality, we're not talking about where is the item before I drop it. We're only talking about after I drop it. Positive time. And if you use your calculator, we do the square root of 15, and we're getting 3.87. So t is approximately 3.87 seconds. In this next example, we have an equation. We have a wave, and when the wind blows more, the waves get taller. The height of this wave follows this pattern of 0.019 s squared. And s is the speed in knots of the wind. It's a measurement that you typically known in sailing and wind issues, knots. So the height is going to be 0.019 s squared. So we want to know when is the wind speed, or what is the wind speed for a 20-foot wave. So the height is 20 feet. We're trying to figure out the wind speed, so we are calculating for s. So we're going to divide by 0.019 because we need to get the s by itself. And when we do that, we have 20 divided by 0.019. That gives us 1,052.63. That's approximate value. So you can use an approximate here on your equal sign if you wish. So we need to take the square root of that, 1,052.63. That's still an approximate type answer. So we'll say the square root. Now watch what I type in. I do not type in 1052.63. I use the answer button. If I do that correctly. Second answer, second negative key, gives you the previous answer. That's a skill that you want to learn to use, a key that you need to know. That's going to be 32.44. And that measurement is in knots because it's the wind speed. All right, our last one. with these types of examples, as a water balloon is dropped from a window at 59 feet, how long does it take it to hit the sidewalk? Well, h of t equals negative 16 t squared plus h of o. Sidewalk is going to be at a 0 height. Your gravity is not changing. You're at a height of 59. So we move this 59 to the other side. So you have negative 59 equals negative 16 t squared. We'll take our negative 59 and divide that by a negative 16, and we get 3.6875. And that's still t squared. So that's an exact answer, by the way. And we are going to take the square root of that amount is the square root of, that's an exact, I guess, if you want to say that. The exact value is 3.6875 inside the square root, which is approximately the square root of the answer. Or you could type in that decimal, because it terminates. But 1.92. 1.92. And our t is time in seconds. So two ways that we have learned to solve quadratics is through factoring and square rooting. Some people would call that undoing. You're undoing the equation. So we can practice those down here. You've got different skills used in different situations, and you can make your choice which method is the best to use. Go ahead, pause the video, and give that a try. So here I've worked through these two problems. You can take a look here on this first one. Notice that this first one has a b term. Because it has a b term, I have to move the 15 over to the same side of the equal sign. Then I can factor it apart. This has an a value, so I needed to make my table. A times c, 2 times 15 makes 30. So I need to figure out what multiplies to be 30 and adds to be 11, the b term. That's going to be 5 and 6. So I plug my 5 and 6. 5x and 6x makes my 11x. I circle my two groups, factor out what I can, use the zero product property to figure out my two solutions. When we moved over here to number 2, we first divided by the 2 to get to 44. Then we took the square root. You take the square root of something squared, you get the value that's inside. When you take the square root of both sides, you have to have plus or minus the square root of 44, which 44 can be broken down into 4 times 11. Because 4 is a perfect square, you pull it out as a 2. You add the 8 to the other side. This is x equals 8 plus or minus 2. Don't call that 10. X plus or minus 2 root 11. Then the last one, it's a little bit different. You could solve this a couple of different ways. You have choices. The common thing to do probably is just go about your business and do it the way that it's written. Since this does not have a b term, this example does not have a b term, you do not need to bring everything over to the same side of the equal sign. You could, but you don't have to. You can just undo it like we did letter B. We use square roots to solve it. As long as there's no b term, you can use square roots. I'm going to reduce this first. I'm going to divide by 2, divide by 2. So x squared equals 1/9. Then I'm going to take the square root of both sides. And we know that when we take the square root of both sides, we get plus or minus. We take the square root of the top, which is 1, and we take the square root of the bottom, which is 3. So you get plus or minus 1/3.